Thank you. Hi, everyone. I will try to make it enjoyable. I asked them. We're going to speak about what we're doing in Clifford Chance, that is a legal firm, around machine learning, artificial intelligence, and of course, Spark, NLP, and Azure Databricks. Let's go to next slide. Yes, my name is Mirko Bernardoni. I'm the head of data science in Clifford Chance. I joined the company in January 2018. Since I joined the company, I had the opportunity to work in this beautiful greenfield scenario without cloud, without data science, and I had to build everything from scratch. This is what we're going to look into today. My colleague here instead.
Yeah, hi, good afternoon. I'm Michael Seddon. I'm a senior machine learning engineer with Mirko at Clifford Chance. I'm working there for about 18 months and solving all of the engineering challenges that working in the legal industry presents.
Yeah, but who is Clifford Chance? First of all, we are a legal firm. It's one of the biggest worldwide. We have offices across all the globe, but we have so many offices, but we are working all on the same way. Now, what we are going to go through today, first steps is how we build everything, how we manage to go from zero to having a working data science lab that is producing value, or architecture, or first success, that usually is nice to know. And a nice research that we did during the summer is about NLP using deep learning in Spark and Databricks. You may have the follow question, why a legal firm is looking in data science? Maybe it looks strange. I think until now I found only another data scientist that is working in another legal firm. The reason is digital. Digital is changing so many different industries and sector, and legal is affected too. Our executive are well aware about that, and they had this vision. In order to be competitive, we have to become a future law firm starting from the current status and embrace digital. What does it mean? First area to improve is digital technologies. What are digital technologies? It includes everything around that topic. Also human argumentation, that is artificial intelligence. This is one of the reasons why we created Data Science Lab. The second area is about digital trends, such as working remotely from home, becomes a better digital organization, and so on. The third area is about new regulation and markets. For example, how we can anticipate what is going next, especially in these days that everything is changing fast. Look, Brexit. But you might be more interested about what we're doing in the shadow, what is our mandate as a data science lab in a legal firm. We seek to better understand our data, the news predict business outcomes, and recommend what to do to achieve our goals. How we do so? We have three big pillars. The first one is called the 360 information products. What we're doing there, we're gathering different data sets, merging together, finding some inside, and show this type of result to our business and lawyer in order to improve the daily work. The second area, the second pillar, is about prediction and prescription. That for us, it means also document analysis, contract analysis, and all the area related to natural language processing. The third area, it's about how we can use our data as asset and generate new revenue because of that. You may already notice that with this three big pillar, we are covering three important key points. First one is cost reduction. Second one is improving our daily work for our lawyers. And the third one is a brand new generation stream. Now, if you think there is a lot of good reason for doing a data science lab, but not everything comes for free and not everything is easy. We made a lot of mistakes. And we try to learn from our mistakes. During the process, we figured out that this is the path that we followed, starting from zero, where we started. The first step was define your vision. In our case, we define our vision, the one that we saw before, what we are trying to do. Then the logical answer is, okay, let's become a better digital company. This means start to know our data set and embrace BI and the different applications related around. It's more or less easy. You don't need cloud. Was an easy step, but give us knowledge about our data sets and becomes a better data-driven company. From there, we were looking, okay, now we want to use the cloud, now we want to use artificial intelligence. What is the easy step to go from there to artificial intelligence? Software as a service. But it's running on the cloud. We are a legal firm, we have a lot of rule, restrictions, and so on. Then we had to address all the cloud challenges in one go. This, on top of that, gives us also another advantage. Our business start to learn what does it mean working with machine learning. What does it mean, for example, preparing a training data set? What does it mean that is not magic? It's not doing everything automatically. More or less, in this point in time, I joined the company, and they asked me, okay, now we want a data science lab because we want to produce real value out of that. How we can do that? So, you know, data science, machine learning, you need a lot of data. Then you have to play with big data. There is no other solution. And this gives us the first small, quick win in order to demonstrate our value. And at the same point in time, we start to get a lot of more and more initiatives and ideas coming inside our lab. For this reason, we created an innovation pipeline that is able to organize and define all the different gates that we need in order to handle all these ideas. Now that we are on the cloud, we start to produce more and more. You know, we start to know how to deal with big data. Why we don't start to use also what we call AI accelerator? What are they? We're using Azure. For us, it's Azure Cognitive Services, essentially. All that set of services that contains a pre-trained model. You know, easy to use is a REST API. And this automatically gives us capability in order to extend existing application or create a new one. As you notice, until now, you might don't need a data scientist. You are using stuff that is ready to use. Okay, the first one is software built by someone else. Okay, nice. Okay, big data is not really data science. And using API with existing model pre-trained by Microsoft is again not really data science. Where was the real challenge here? Dealing with the business, because each one of these ideas is changing their business process, is argumenting their daily life in a completely different way. Then define exactly how to do so, how we can help them, and shaping all these ideas in a proper product is a different story. But if you're doing so, why we are looking for data science lab? That is the final step. Solution, again, two important points. The first one, data scientist, contains the magic word scientist inside. Then the expectation is you have to do academic research, reading academic paper, and so on. What does it mean in practice for our business? We get at least between like 3, 5, 10 years of advantage on what is going next on the market, especially in our area. And this is a huge advantage. The second is having the capability to create your own model. This means that we can create whatever product in order to solve whatever problem, if it's solvable. Again, also this one was not coming for free. Different challenges also here, such as we have to operationalize this effort because we are working end-to-end. We are building products, not models. We have to deal with so many different departments. It's not easy to deal with maybe with all the mindset type of IT, especially in a traditional legal firm, and so on. Okay. Moving forward, I mentioned that Data Science Lab for us is end-to-end capability. What does it mean in practice? We are not speaking only about research, first of all. We start from ideas and the business process management. How we can improve their life on a daily basis. What does it mean if someone comes with an idea, and how we can, get something better than what he's proposing on that. Moving forward, we always ask about, for example, return of investment, what are the benefits, monetize everything, because in that way, we are able to give a different priority to these ideas and decide which one is more worth to get realized inside Data Science Lab. When we get there, we have 3 steps. The first one is data pipeline. In our case, we have a lot of confidentiality to deal, a lot of compliance, regulation. This means that the process can be long in order to get through all the different gates, having all the approval, and be sure that we are taking the right data that is allowed, for example, to go to the cloud. When we have all these things agreed, we can move forward and do the classic data extract transformation type of exercise, where Spark is really good. And this gives us the right data in front of the right person in the right shape. Who is the right person? The data scientist. At this point, he can do his job. For us, not all the data scientists have the equal access to the data because the regulation that we have, because confidentiality. This means that maybe my peer, close here, he cannot see my project. And you have to deal also with that type of complexity when you handle your data in your data lake. Data scientist does his job, do maybe some academic research, work with a university. Moving forward, we get some models. And now we can finally create a product. How we do so? We are following minimal viable product because we are always working really close with the business. Business is part of our team. Then we want to iterate as many times as possible and improve gradually in order to give a real value at the end of the story. You know that when you do data science, you touch on a lot of new technologies. And because of that, we become technology pioneers too inside our company. If you're speaking about Spark, Kubernetes, and so on, usually you come in the data science lab first because we are using that type of technology on a daily basis. Automatically, we have to become DevOps, SecOps, operationalization expert. The team is really small, then everything needs to be fully automated. There is no space for I do something manually. Just press a button, it has to work. Evangelization, because we have all this knowledge, we are sharing internally a lot. Sometimes we are doing conferences too. We are touching also data literacy type of problem in our company. As you can see, there are a lot of services that we are offering that is not only the pure product development. Now, a lot of good speech, business, etc., but let's see something more practical.
So the whole legal industry is basically built around confidential matters. You know, everything is confidential. In our company, literally everything is confidential. That's our business. And so when we're talking about architecture, especially related to data science, we need to understand, is it appropriate? And to answer that question, we need to really understand what we mean by confidentiality. So the star of the law firm is the client, which makes sense. Our relationships are defined with the clients through contracts. And effectively, this lays out what we can do with their data. With regards to confidentiality, there are three main things that we need to consider. Firstly, there's user access. Who can see and work with what data? As Mirko said, you know, within the same team, there are different levels of access. With our team, there are different levels of access. Enforcing these sort of data fencing requirements is really difficult, and especially when you come across, you know, time validity, which is what's valid today might not be valid tomorrow. What we can do with a client's data this month might change next month. And with this combination of these two things, it gets really complex to actually enforce, especially when we're processing hundreds of millions of documents. You know, that stuff is hard. When we also factor in individual contract limitations, like I'm not allowed to use your data in the cloud, or I'm not allowed to use part of your data in a machine learning model, that stuff gets really difficult. What we also need to take into account is audits, and these happen all the time in law firms. Effectively, what this means for us is that every single row in every single data set needs to be treated individually and really, really carefully. I mean, you know, GDPR has been mentioned 1,000 times at this conference. That's easy compared to this. You know, we need to be able to prove what we've done, when we've done it, why we've done it. It's difficult. And so not only to do jobs as data science people, we need to be able to handle these crazy changing requirements. So our architecture has four main pieces. The first is data processing, which is effectively dealing with the filtering from on-premises. We use a pure on-premises Spark cluster to deal with the filtering requirements, which which allows us to make sure that we're doing the right thing with the right data. The data engineering piece deals with having the right data in the right place, in the right shape, so that the data scientist can step in and do your job. Having a unified platform across data processing, data engineering, and data science is important because, as Mirko said, we've got a small team. It's important to make it efficient and as productive as possible. It's also got an advantage that, you know, if a data engineer is off sick and there's a problem with the pipeline, a data scientist can step in and hopefully fix it. Finally, we've got our line of business, which effectively operationalizes the work of the data scientists so that, you know, we can justify our existence. What this looks like in practice is effectively this. We've got our on-premises Spark cluster on the left, which where the data is replicated via Kafka. In the middle, we've got our data engineering piece, which is Spark on Databricks, which allows us to move and transform and do all the fun stuff within our data lake. And then we've got our data scientists working in that same environment, you know, accessing all of the great things that that environment provides. We've also got down in the bottom here, Kubernetes-based services, you know, to really nicely serve all of our clients and internal business needs. And yeah, it works really, really well. The problem, which you might be thinking, is that's probably going to be a little bit expensive to maintain, and we've got to justify this, which makes sense as a business. So, you know, I'd like to talk about our first success, which is related to graph analysis, or more specifically, client relationship analysis, understanding our client relationships. So this use case had three justifications, or three main reasons for existing. The first is to obviously understand our customer relationships, because it's critical to our business. It's also critical to future revenue generation. The next is that our customer relationship management system sucks. It's really hard to get people to use it. It's old. People don't have any time during the day to do it. Finally, we want to use our huge existing data to uncover insights into our customer and client relationships, because that's kind of what the whole point of data science is about. So what you're seeing... Oh, no, sorry. To ensure the success of all of our products, we go through the same process. First, we define KPIs, which I'm sure you can appreciate are confidential. We define data sets, and so in this case, it was our email system, our HR system, our CRM system, and you know, other internal client information. Next, being good scientist people, we do academic literature and research, because it's about knowledge graphs, graph algorithms. We want to make sure that what we're doing is right and correct and proper, and if it turns out that we're not, then we go back to the dataset definition phase. That's cool, you know, we're agile, it's fine to fail, that's fine. Once we're sure we've done the literature and research phase right, we move on to the demo realization. Effectively, this is where we interact with the business to make sure that what we're delivering is what they want. We don't want to run away and make a bunch of stuff that nobody's ever going to use or care about. And if we've got it wrong, then again, we iterate. We go back to the dataset definition phase. That's fine. If we haven't got it wrong, we start to do some user visualization. We start to implement the research that we found. And obviously, we're always doing further dataset analysis to make sure we've got the information that we need. Once we're cool with all of that, we move on to production. We create a minimal viable product, like Mirko said. We productionize the research, and we set up the agile project scaffolding that's important for the long-term success of anything. So what this actually looks like is this, and using the confidential word again, this is a very minor subset of what we've actually produced for this demo. But effectively, we analyzed 100 million emails over a year with some of our key clients. Due to the sheer volume of that, we had to use Databricks, and it worked great. And we figured out some interesting metrics related to relationships. Propagation effectiveness, like how good are you at getting a message through a system, or how influential are you, how many important people do you know, those kind of things. And, you know, obvious things like sent and received emails, all of the standard stuff you'd imagine with relationship type stuff. Oh, good, it stopped. This should loop, by the way, but it's not, so cool. And so by presenting it in like a different way to traditionally, it lets us immediately see insights about the individuals and their relationships with our clients. But we don't just want to see the individual. We want to understand the wider community relationship around that individual, and also give context to the mathematical concept of a community. What are these people talking about? Who are they working with? Where are they based? General things about a community lets us really understand both the individual and the community much greater than if we're just looking at one of these effects. The whole point of this is basically to identify the key players within relationships. We want to understand why they're the key players. What are they doing? We want to understand how we can help them better. It's all related to relationships and clients. And, you know, the star of the law firm is the client. The better relationship we have with them, the better our business is. And so, you know, spinny 3D graphs are really great and they're fun and they're nice to present to senior management types, which is a great tip, by the way. But we're actually doing some proper work in the lab.
And it's not really proper work. I was speaking about research that has been done. That one might be more interesting. What is the problem? Problem specification is document classification. That is not text classification. I will go more deep later. Why we're doing so? I don't know if you're familiar with LIBOR, Brexit, repapering. Essentially, by time to time, there is this huge repapering exercise happening, maybe in the banking industries, finance industries, and so on. Does it mean for a legal industry? You have a client coming with there. Oh yeah, I have like 10,000 contracts. Can you please review this? Boom. What does it mean, 10,000 contracts? That each one of the contract is not one file. Each one of the contract can be also 10, 15 files. Because maybe the initial version, then you have a different annex, then you have a modification of that and so on. If you're lucky, it's everything in the separate folder. Otherwise, everything in one folder. As you imagine, classic, what we do usually, or what people do often, you go through manually and try to identify which document are needed for your lawyer in order to give the right advice to your client. This exercise is about try to do this classification automatically. Okay, how we did it? Usual process, KPI, dataset. Because it's a research, we went directly to Edgar. It's a security exchange from US Security Exchange Commission. You have a lot of data there if you're interested about this type of problems. It is for free. Then we went through academic literature research, looking the problem. First attempt was, okay, let's see what we can do text classification. Wrong, this doesn't work. Document classification might be better. Then we went through deep learning using natural language processing. Then the usual type of iteration, and we stopped there. We're still research phase. We don't have a demo. Most likely we were not going to do a demo in this specific case because we were looking to extend the existing application. Then the output will be a service used by an external application. And we will go directly to MVP phases. How it looks like one of these documents. Here are some example, public. You can see like maybe Coca-Cola that was trying to acquire some other company or something like that. You can go easily 300 pages, more than 150,000 words, and so on. And you may imagine, if you're looking like BERT, an actual type of models, they don't work really well with such huge type of documents. What we did, first step is, I want the data, like everyone else. Okay, we have this US security exchange, etc., looks cool. But it's HTTP access, then okay, we find out that there exists an open source application called OpenEdgar that allows you to download these files, but wasn't working in Azure. Then we did some modification in order to make it work inside our environment. We scale it using Kubernetes. And what was the final result? Okay, we get a blob storage that contains all these documents and a metadata storage that is really beautiful because it's a PostgreSQL and it can run query, identify maybe the type from my metadata. But it's not enough. It's documents. Then you can get everything. Then you need to go through, first of all, document analysis, see what you're dealing with, then document cleaning, define what you really need to keep, what you need to discard, and then text extraction, having a text in the right format, because maybe are XBRL, there are HTML, PDF, and so on. In practice, we started from 15 million of raw documents. We end up to find, okay, 7 million are real documents. The other are JavaScript, GIF, images. There are a lot of HTML files, then you can imagine. And from this 7 million, we took a subset of 250,000 that are more close to the type of document that usually all lawyers are working with. Now that we have that, finally we can do the real job. Yay! We can work and develop our models. We use cross-validation, 10 dataset of 1,000 documents, and we consider different model architecture. Nothing too strange. You see like CNN, LSTM, Doc2Vec, SVN, BERT, etc. We try almost everything in order to see which one was fitting best for this type of exercise. Do you see where is the real problem now? You want to compare different model, different architecture, but you want to be fair. This means that you need to optimize your hyperparameter because you want that each one of the model is working as best as it can. Then how we can choose these hyperparameters? We use two different techniques. One was grid search. It's kind of brute force, essentially. And the second one was using Bayesian optimization. It's not enough because not everything is running on PyTorch and Keras. Especially when you go in natural language processing, you may be aware there are so many different libraries that have some good algorithm implemented, or you find some research. And you end up on this type of annoying problem. have, a model that runs only on a single core or essentially really run badly on a multi-core system, how you can scale this one in order to do a proper hyperparameter search in a decent timing, because you have so many different variations to consider. Fortunately, we have Spark. Then what we did, we take an RDD and we fill all the possible combination of hyperparameter inside that RDD. Now that we have an RDD filled with all these different, I know it's old school, all this type of different combination, and it's huge, we end up, okay, cool, we can use a map function. Now, if you apply a map function on RDD and that RDD is well parallelized across the cluster, you end up in this nice situation where your single core model is going to run just on one CPU per executor. And this allows you to scale as much as you can pay. In short. The other things that we did, okay, we want to use miflow. It's good, to store model information and then do the comparison. Why not? And then we used, some data frame for additional information. Pay attention about this specific architecture. I give you a couple of slides, and I come back with a question. There is something wrong that might not work as is today, or as it was this summer. This is how miflow is looking. Okay, nothing new. You see miflow. We used a lot confusion metrics because it's a classification type of problem, and having the capability to put everything in a nice UI. When you have a subset of model, compare quickly was really, really helpful from our point of view. In this type of use cases, usually we go via grid search. As you can notice, it's shooting essentially everywhere. You don't have a good optimization at the end of the graph. As you notice, it's going almost everywhere in order to try to maximize AUC. Now, coming back to my point, did you notice what was wrong on the architecture? What might be not work? No idea. Okay, this one. miflow doesn't deal really well with multithreading when you play with Spark. We found that there were a couple of closed bugs on GitHub, but it was like I won't fix. That's okay. We try to contact them, fine. Try to do by ourselves. This is what we did. The solution is trivial. Why we don't use? We created just a class, as you do as a developer, instead of using global variables. And then we just implement enter, exit, and del in Python, and you get essentially the same syntax. How it looks like? This is the class, copy and paste, honestly. Exactly the same method, small differences. The only area that you have to look on the left corner, enter, exit, del, and the structure, they need some adjustment there. And when you're going to use it, use with. Instead of experiment, you can put miflow, no difference. This is essentially how we solved this time of glitch. The second area is when you use PyTorch and Keras. Then you're working on your notebooks inside Databricks, like we are doing, and you have a deep learning model that is using as many CPU or GPU you can provide. Fortunately, we can use Hyperopt in order to do all the optimization. It's like, great. But Hyperopt is not going to scale on Spark. Then Databricks created Spark trials. That what it's doing in practice, taking your deep learning model that is running on as many core is going to find, or GPU, depending how you write it, essentially, and make sure that you have one run per node, per executor. In that way, you're optimizing exactly how you're doing the hyperparameter optimization. miflow is almost coming for free in this context, and we end up to have our optimal hyperparameters combination as a result. Again, this is just a couple of lines of code. This is how it looks like. You just define the subset that you want to try in your hyperparameter, and just say, okay, please run this. Wait a little bit. You do something else in the meanwhile. And when you come back, maybe a day after, you have all the results ready to go and ready to compare with the other models. Bayesian optimization, as you can notice, it started to shoot a lot more close to zero. This is a loss, then you try to minimize this one. And, it's a kind of working. It's going as close as possible to zero instead of shooting all the possible direction. What we gain on this type of design, we gain that if we're going through a grid search, we reduce it a lot of time. If you look at elapsed versus the total CPU time, it's just crazy the amount as usual. But more interesting, it's the result that we get on this research. On the test datasets. With the cross-validation, we get a 98.5% F1 score. That was really good, looking at the type of documents that we achieved. In short, what we went through today, we were looking about how we build essentially everything, how we design the full data science lab starting from scratch. The next steps was about architecture, and then we went through the graph analysis use cases and the deep learning one. Do you have any questions? Yep.
Test. I suppose you are trying your model with U.S. law, because you said you use some data from U.S. Securities and Commission. Have you tried it with other countries' law, for example, Dutch law or Belgian law or German law or something?
You have to consider this text. Then if you use German law, everything will be in German.
Yep. Definitely, that's one of the things.
We don't speak German.
And even there are some countries which share the same language. For example, like Belgium use some French and Dutch. France definitely uses French, but still you have different law.
Yes, then you have to retrain everything properly. Of course, different law, different country, different languages. If you look only English, we know by fact that if we're going to run exactly the same model, we'll have a different result if we apply it to the UK law, because the semantics is different. Also, if it's a really similar language. If we're going in Europe, where almost every country has a different set of languages, then the challenges is also about the language itself. And this means, for example, when you work in this type of field, or knowing that specific language, or having someone on your team that is fluent and know really well that specific language in order to also understand why the model is not working correctly.
Okay.
Hi. On the graph analysis that you did for the relationships between, I guess, lawyers and clients and, I guess, other entities, what are the main benefits that your people are getting from that?
So the whole point with law firms is their relationships with clients, and so any insights into understanding them better is immediate. There are a lot of things that obviously I can't talk about due to confidentiality, but better understanding relationships and the key individuals within those relationships is critical to fostering and creating new relationships. So effectively it strengthens them.
Okay, thanks.
Hi, I have a question about document classification. You have a nice score, but you didn't mention how many classes or categories do you have in your training?
Yes, we used it was 6 different classes that were coming from different type of documents pre-classified by the Security Exchange Commission. This means that we use the metadata applied to this specific documents in order to define the classes. On top of that, just to give the full overview, often on these documents, the first page or the first set of lines are standards. Then we remove that one in order to, make more realistic that specific.
Hi, another question related to document classification. What is the ultimate? I guess one of the interesting stuff also could be to get kind of nice search engines for your lawyers now, where you could apply many different classifiers to extract some really interesting semantic features that help.
Not really. The goal for document classification, the core goal in the beginning is this one. Like I said, if you have a LIBOR repapering exercise, there are different steps in order to go through and define, for example, where you have to change that specific loan amount following the new regulation and so on. The point is, in order to do so, you have different type of loan, for example, inside the same bucket that are thousands of this contract or loans, etc. Then what you want to do is, first of all, identify the different type of loan. Then between them, identify what are maybe the relevant files that you need to check. Maybe an annex is not something that is really interesting. And then you end up with a short list of these documents that you use maybe in another application for extracting all the relevant information. And then on that, you start to do all the different steps that you need in order to finish the job.
Okay.
Then it's not really search, it's more like reducing the data set, because you have maybe, I don't know, 7, 8,000 or 10,000 different loan or contracts. Each one can be up to 10, 15 files. Then you just do the multiplications that will become, really huge and massive amount of data to handle manually.
Okay.
Yeah. Hi. Here, next question. Yeah. Thanks for the presentation. This was a nice one. I have a question regarding the evangelization. Here, this is me. Yeah. Yeah. I have a question regarding the evangelization that you did in the company. How did you structure your team to achieve the evangelization, and how strong is it? Is it top, bottom, bottoms up?
Okay. Just to recap, how we did evangelization. The first things, it's we don't want to have lawyers becoming a data scientist, and they are not interested too. What we really are looking for is to speak the same language. This means having a set of common definition. If I speak about machine learning, both of us, we know that what about we are speaking. If we speak about unsupervised training, they know exactly what we are going to speak. We are looking to have the same semantic in order to speak the same language. How we structure that? Essentially, we are doing a small group of people, kind of small teams. We will go there, and then we start following, the usual type of training and speaking. Okay, for us, this is the definition, and then we give them example related on their daily work in order to move forward. Because another really important thing is given the right context. Otherwise, it's difficult for everyone to understand why you need that set of definitions.
It's also really important to set expectations, because just because it's a computer doesn't mean it's going to be able to do everything and perfectly. It's an important part of it.
Is it difficult to do in a legal firm?
The lawyers are very clued up. They really have a very good base level of understanding, and so just having a conversation and introducing concepts is very, very powerful.
All right, so we have a couple of minutes, so we take last question. Last one. Oh, yeah.
Hey, how big is the entire team, and how long did it take to build the complete infrastructure, for example, the whole security issues?
Okay, let's say security challenges. The team is really small. We just grow to 3 core members. What we are doing, usually depending on use case, what we are looking to do, we might be working with partners. We work a lot closer with universities about the security piece. Getting all the infrastructure up and running. That one requires a little bit longer. It's more or less. It's difficult to define because in 6 months I had the capability to connect to Azure, and be able to spawn a virtual machine. And then it's just multiple iteration based on what we are trying to achieve. It's not trying to build everything in one go. It takes forever, but it's taking specific use cases that you know exactly what is the value that you're giving to your business, and implement that one. And use that one as accelerator to build your foundation on your architecture and so on. What we spend, as just investment in the beginning was defining the initial architecture, like the diagram that you saw there, and so on. And we say, okay, this is where we want to go when everything is up and running. And gradually we start to build all the components we needed with some selected use cases in order to have everyone happy. Because when you finish to implement that specific, you give value to your business. Because you give value, it's mean money, they are more happy to continue to fund you.
All right, so thank you so much for fantastic talk, Michael and Mirko. Yeah, so
Thank you.
I hope you guys
Thank you.
enjoy the rest of Spark Summit. Thank you.